So back to our problem here. So tan of 60, and like I said before, it's a 30, 60, 90. So if you want to do, that's where going from 5 to x, we would divide by radical 3. Okay, if we're going this way around the right triangle, we would divide by 3. Divide by radical 3, I'm sorry. So, but we could also use trig. So we do tangent of 60 equals opposite over adjacent, so equals 5 over x. Where's x? X is on the low side, so you switch this over and you divide. All right, so 5 divided by the tangent of 60, and that gives us for x approximately 2.89. All right, so now that we have what x is, we have to find what the perimeter is, okay? So remember, that is only part of that side. That is only, here, I'm going to erase some stuff here, guys. That is only this part. So it's only half of that side. So that's where it's back to perpendicular bisectors and everything like that. But a perpendicular bisector cuts forms a right angle, and it also, since we have, all sides are congruent, we're going to have this side is equal to that side. So the one side is 2.89, meaning the other side is 2.89, meaning the whole thing is going to be 5.78, the whole length of the side. Now, how many sides do we have? 6. Okay, so to find the perimeter, we just do 6 times 5.78, and that gives us 34.68. All right, so that's our perimeter. Okay, so we found our side length from using trig, found the perimeter, okay, because all we did was we found the whole length of the side. That whole thing is 5.78, multiplied it by 6 because there's 6 sides. And then we just plug it in our area formula. Use a different color because I know we got a lot going on here. So let's use blue. All right, so the area, we already know what the apothem is, okay, is 1/2 the apothem, which is 5, all right, times 34.68, which equals, for our final answer here, 86.7 centimeters squared. Or meters squared, I'm sorry, meters squared. So all right, so that is going to be our answer for that one, 86.7. Now, moving on to number 4. Okay, we're going to do the same exact thing, except this one with number 4, it's a little bit easier. I'm going to move up because we're just going to go through the steps, but they're not going to be there, all right? So look back on the note sheet or whatever if you need to see those steps. It might be good to print that. And the steps I'm talking about is 1 to 3 up here. Yeah, you might want to steps to find the apothem or side length. It might be good to print 1, 2, and 3 out for you if you can, or just take a picture of it on your phone. That way you have it. So number 4, this one, triangle. Okay, so we know that if it's a regular polygon, it's an equilateral triangle. So if we draw form our right, wow, that was good. Form our right triangle there. This angle over here is going to be 30 degrees because this angle is 60 degrees. It's an equilateral triangle, okay? So 30 degrees, 60 degrees, because it's half, okay? So this one, you could do n minus 2 times 180, but I think we know that the sum of all angles in triangle is 180. We divide it by 3 to get 60, and means that angle is 30 degrees. So looking at another 30, 60, 90 right triangle. Now, we're looking for this length over here again, because we need to find the perimeter. We know the apothem, okay? So for this one, we could do, since it's opposite the 30-degree angle, we could just do 18 times radical 3. Now you could also use trig and use tangent.